And then I forgot. So if I remember, I'll say it. But what we're going to do today is half of 3.4. There's like so much stuff in this class though, right? Every day. Okay, so hopefully y'all grabbed one of these things down here. Got a few different colors. Let's see what we can do with this. So after today, you should be able to do half of the 3.5 homework, okay? On Friday, what? Nope. Wednesday, we'll do the second half of 3.5. And then on Friday, we'll do 3.6. And then on Monday, we'll review for exam 2. And on Wednesday, we'll actually take exam 2. I know, it's like whiplash. And I think we actually did just start week 18. Yeah, y'all grab these. I think we actually did just, no, week 18. It feels like week 18, but like week 8. So it means that like we're now officially in the middle of the semester. I did look this morning and it says that midterm, like the portal that I used to enter grades has opened. It actually opened on the 9th and that it closes on the 19th, which means if y'all don't take your exam 2 until the 21st, like technically what I'm going to go ahead and do now is just whatever grades you have at this moment. Okay. So of course, just know, like if y'all asked to see it last Friday, like you should kind of know where you're sitting after you take exam 2, depending on your performance, like, you know, your grade would go up or down. But for the midterm, I've got to meet that deadline. Okay. So on the 19th, I've got to have where you're at right now, this moment. So just make sure that if, you know, you don't know and you want to know and you don't want to find out just that way, like you could ask me. We don't enter in A's, B's, or C's. Okay. For the midterm grade, the only thing they have us enter in is if you have a D or if you have an F. So that's what I'm saying. Like, if you don't know for sure what your grade is, you could just go ahead and ask me. Okay. But yeah. What, Dylan? Yeah. I'll just need to log on real quick and show you. Okay. Okay. I'm going to try to use this pen today. I've got a blue one. I've got a purple one. The pass out, I actually want to write on it. You know what I mean? And like, y'all know my handwriting doesn't really cooperate. So I don't want to try to use a marker and it be too big or anything. The first thing I want to do whenever we start this section, so it's 3.5, right? On the other page, it actually says it, y'all. This is rational functions. Y'all, rational meaning like it's written in a ratio form. And so what you have is a function that has x's in the numerator and x's in the denominator. And so it's not just any fraction looking function. There's got to be x's in the top and in the bottom. I'm going to do 2 quick examples of finding the domain, and then we'll start the packet, okay? So, and this is and should be like a refresher type of thing because we've been doing this. Find domain. So let's say for this example, we have f of x equals x squared, and that's a -9 or a -9. And then x, I kind of want to do a different example for a specific reason. Because that one won't cancel either. Do x -3. So in my example that I have here, I did x -4, but I'm actually changing it. I want to do x -3. I'm going to show you, of course, just like a refresher on how to write the domain of a function, right? But then I want to give you a little insight into where we're going. So it's just going to be like a little asterisk side note, okay? So if we're going to find the domain of a function, if it is written as a fraction, y'all, you could use your little packet thingy here. I think it's like almost the last page. Rational functions and their graphs. So this is just saying f of x equals, it's p of x over q of x, where q of x doesn't equal 0. That's just saying a polynomial over another polynomial, which is why they both will have x's, right? Because they're polynomials. And then it's basically just saying right here, the domain of a rational function is all of the values x except for those that make the denominator 0, right? Like we've done this before. And the way that you figure out, well, what makes this denominator 0 is to set it equal to 0, right? So same thing we've done. So we're going to find the domain of this function. I would literally take the denominator, which is x minus 3, and I would set it equal to 0. And then if you solve this, wouldn't I just add 3 to each side? X, those cancel, equal 3. But as far as writing it in our interval notation, that's the value x can't be, right? Because if x is 3, y'all, it's 3 minus 3, 0, right? Like that's why it can't be 3. So what we would write for our domain would be the fact that it will cover all real numbers except for the number 3. And so we're going to show that by writing it in this form, right? Do you see how it goes from negative infinity to infinity? Great, like that's all real numbers. But this right here means that it's excluding that value 3, right? We've done this, not a problem. Now this is my little asterisk side note, okay? Because it doesn't really go into it much in this lesson plan. But I want to like just show you for sure so you know how to do it for the homework. Let's say that we have x squared minus 9 over x minus 3. So it'll ask you like, what's the domain, right? So our domain would be this in interval notation. What we're going to learn is called vertical and horizontal asymptotes, okay? So this is the only thing I want to show you. Do y'all see how that numerator is a difference of squares? That's that factoring technique that you can do whenever you have ax squared and a constant but no bx term, which just means that you use your template here. Y'all, if I go back and FOIL this, don't I get back to this? Right, it's in that video. It should be in that video. But this is called difference of squares. If we're actually finding our asymptotes, which is what we're doing in this section, you'll notice the first part of the homework, it'll ask you what are the vertical asymptotes and what are the holes. Okay, so the vertical asymptotes, I'm going to tell you how to find all of that. But in the homework, if it's asking for holes, what it means is, do you see how what I did was I factored what could be factored, right? I noticed that that's a squared term. I know the difference of squares. I've factored it. Do you see how these are the same factors, so they cancel, right? So what we would say here is that that factor would be a hole. Okay, so in the homework, hopefully that makes more sense. If you notice, hey, I can factor that, go ahead and factor it. Whatever cancels, those are called holes. Okay, that's really the only thing I could think of that isn't really explained that well in this packet. Okay, so and what we just did here, y'all, that's how we find our vertical asymptotes, but I'm going to explain it more in the packet. Okay. Okay, so let's start this. I don't really know how I like the purple pen. Let's try the blue. So 3.5. Oh, see, I did put holes here, but that's kind of what we just did here. Okay, if it's factored and things cancel, those are your holes. Okay. Okay, so basically it's just vertical asymptotes. A vertical asymptote is a vertical line that your graph never crosses. And the way you find your vertical asymptote is to set bottom equal to 0, set your denominator equal to 0, which is what we just did, right? Like that's how we're used to finding the domain. That's also how you find the vertical asymptote. So you could put set bottom equal to 0 or set denominator equal to 0. Okay, so this is what your answer looks like. On a graph, it's literally a dotted vertical line, like little slashes. I put dotted. Whenever I actually draw it, I kind of do like little slashes. It's a dotted vertical line. If you're asked to find a vertical asymptote for the homework or for an exam, the answer on paper just looks like X equals a number. Like a second ago, we did this and we got X equals 3. That's our vertical asymptote, the X equal 3, okay? So, but on a graph, you would at say 3, you would go to X equals 3 and you could do like a dotted line, you could do a dashed line, whatever. You're literally stating that this is a part on the graph that that it can't be crossed. Okay, so for horizontal asymptotes, okay, so it doesn't really make a ton of sense, but the way you find horizontal asymptotes is Bob, bought, and eats. Okay, and I'm going to literally describe it. It's basically just an acronym to help you remember. So BOB is bigger on bottom. And what I mean by bigger on bottom, the exponent on the bottom is a bigger degree than the exponent on the top. So on the bottom, you have like X squared. On the top, you have only an X. That's bigger on bottom, right? And the horizontal asymptote for when it's bigger on the bottom is 0. Okay, so it's literally just Y equals 0. Our vertical asymptotes are going to be shown with X equal. Our horizontal, right, that goes this way, that's going to end up crossing our Y axis. So that's why it's horizontal, and it would be Y equal. For an exponent that's bigger on the bottom, it's Y equals 0. Okay, so if there's one bigger on the bottom, BOT would be bigger on top. Y'all, N just stands for none. There's none horizontal asymptotes if your exponent in the numerator is bigger than the 1 on your denominator. So you just write none. And then eats is exponents are the same. So in the denominator, I have x cubed, and in the numerator, I have x cubed. If my exponents are the same on the top and on the bottom, what we do is you divide the coefficients. Okay, so exponents are the same. And then, so what you do, your y is equal to divide coefficients. I have a little example of an eats, but I did like f of x equals, say we have 7x over x minus 2. So in the numerator, that degree is 1, right? X to the first power, degree 1. Denominator, that degree is 1. So what you do is you would divide the coefficients. And so the coefficients here would be 7 over 1, which equals 7. So our y equals 7. That would be if you look at that being graphed, you would notice that there is a horizontal asymptote at y equals 7. And y'all, there's like more detailed stuff too in this packet. Like your graph could never cross a vertical asymptote, but it may cross a horizontal one. You know what I mean? So just, yeah, you can read this. Okay, let's see. So your answer looks like, okay, so on a graph, horizontal dotted line / line. It's just, you can notice it not being crossed. Horizontal. And then on your paper, if you're asked to tell me what the horizontal asymptotes are, well, if it was bigger on the top, you're literally going to have y equals 0. If, I'm sorry, bigger on the bottom, y equals 0. I've read it and I lost the wrong word. If your exponent is bigger on the top, then your answer would just be none. And then for each, where your exponents are the same, you get y equals, what you do is you divide the constants, right? But do you agree with me? All that's going to end up giving you a number. So y equals a number. Okay, So vertical asymptotes, horizontal asymptotes, and then there's slant asymptotes. It's a really fun word to say, y'all. Okay, so your slant asymptotes are going to happen whenever the degree on the top is bigger by 1. So I just wrote when degree is bigger on top by 1. And what I mean by that is like by 1 degree. Okay. You would not have a slant asymptote if numerator is x to the 4th and denominator is x. That's not bigger by 1 degree. That's multiple degrees. Okay. If the exponent on the top is bigger by the exponent at the bottom by 1 degree, then this lets you know that you will have a slant asymptote. And the way you find these, y'all, the equation of a line is y equals mx plus b, right? That's actually going to be how your answer is for slant asymptotes. And what you do is y equals, so you're going to do the top divided by the bottom. And your options are to either use synthetic division or long division. And honestly, y'all, I mean, I would use synthetic division. You literally are just going to take whatever's in your numerator, divide it by whatever's in your denominator. And at this point, looking for asymptotes, we don't care if the remainder is 0. Okay, it's literally just perform that math. And then the quotient that you have left, that gives you your M and your B. So you have the equation of a line. And so then it's like that tells you what your slant asymptote is. So y'all, on graph, slanted, dotted line. And then on paper, that's the y equals mx plus b. And then we've also been finding X-intercepts. The way you find the X-intercept here is going to be to set your numerator equal to 0 and solve. I'm going to say top equal to 0 and solve. And the way you're going to solve your Y-intercepts is to plug 0 in for your X's and then solve for Y. That does not look like 4, but that's 4, F-O-R. Plug in 0 for X's, solve for Y. Right? Because it's a function. It's like f of x equals, and then we have this fraction. So to find our y-intercepts, we're going to plug 0 in for these x's, and then we know f of x is also y, and so we're going to solve for y. And then test points you're going to get from table on your calculator. That's why I sent that email saying to bring your calculator. Even if you don't have it, it's not too hard to find it like at all. From table on your calculator. Okay. So that is all of the process needed to find vertical asymptotes, horizontal asymptotes, slant asymptotes. And it doesn't mean you'll always have all of them, okay? And then you'll need to be able to find your X-intercepts and your Y-intercepts, and then get test points because you're actually going to graph it, and it's not as obvious as it used to be as far as graphing now, because we're going to have stuff that kind of goes everywhere. Yeah, I don't like seeing what I wrote on the previous page. Okay, y'all. So what we're going to do is this first problem, which is f of x equals 3x minus 3 over x minus 2. So if you look at your vertical asymptotes, it said that the way we're going to find them is to set our denominator equal to 0, right? So what's my denominator? X minus 2 equals 0. I'm kind of working to the right, y'all. So what do I get? X equals 2. And so that's a vertical asymptote. Okay. What we would do here on our graph, I don't think I would be able to get the whole page on here like the whole time. On our graph at X equals 2, you can go ahead in some way, shape, or form at X equals 2. I just did a line there, y'all. And you don't have to use different colors. You can have it all in pencil. Okay, I just wanted to kind of show y'all what I'm doing here. It's funny. I thought I was going to write on a yellow paper with a yellow marker. That ain't happening. Okay, so for horizontal asymptotes, we have bigger on the bottom, which would be 0, bigger on the top, which means none, and then we have exponents are the same, and what we would do is divide the constants. So if you look here, what I have is 3x minus 3. I just care about the x, okay? That exponent is 1. And the denominator, I also have 1. So this would actually be, and exponents are the same, divide constant. And so our y, which is going to tell us what our vertical asymptote is, if I look at the coefficients of the coefficients for my variables, I get a 3 in the top, and then that's a 1x. So 3 divided by 1 equals 3. So y equals 3. So this is telling me that this function has a horizontal asymptote at y equals 3. So go to your graph, and at y equals 3, we're doing a horizontal line. So that would be right here. Okay, so our slant asymptote, like if there is one, is whenever your numerator, its degree is 1 higher than the denominator. Because they're the same, then you just write none. There's not going to be a slant asymptote for this function. For this, so the degree is the exponent. So here what we would have, I don't really know where to, let me see. So the degree in my numerator and the degree in my denominator would be 1 and 1. Because your degree is your exponent on your variable. So if that was like x squared, its degree would be 2. X to the 4th, its degree would be 4. It's literally just whatever that exponent is. Okay. So for our X-intercepts, what you do is you take the top equal to 0. My top, whatever, like my numerator, is going to be 3x minus 3. So if you do 3x minus 3 equals 0, what would we do? We'd move our 3, right? So we would do plus 3, that's 3x equals 3. Now we divide by 3. Those 3's cancel. I get x equals 1. So this is an X-intercept, right, y'all? That's where it crosses at my x-axis. So isn't that a coordinated point, right? Anytime we've ever find intercepts, once we figure out what our intercept is, we would then go ahead and like write it like that, 1, 0. And so what you can actually do here is go to your graph at 1, 0 and go ahead and like plot a little point right there. Okay, so for our y-intercept, what we do is we plug in 0 for our x and we solve y. can solve y. Okay, let's like solve 4y, right? So if you look at our function, y'all, f of x can be written as y, right? So I literally am going to write it as y because that's what I'm solving for is y. So I get y equals 3x minus 3 over x minus 2. I need more room, but okay. So we're going to go this way. I'm going to plug in my 0. I would get 3 times 0 minus 3 over 0 minus 2. Now I'm going to go down. 3 times 0 is just 0. And then we would have our negative 3 left, right? And then 0 minus 2 is just negative 2. And so a negative divided by a negative, we would just have 3 over 2. Because I'm graphing it, I actually don't want to, like, you're not going to graph a function. You're not going to graph a fraction. So like go ahead and you could use either your calculator or just divide 3 by 2 and you would get 1.5. That's going to be way easier to find on a number line than 3/2 unless you just know where it is. This is my Y-intercept. So it would also go into a coordinated point. It's 0, 1.5. And so we can literally graph that. That's 0 on the x-axis, which just means you stay at the origin, go up 1.5. So you would be approximately here. Okay, so from this data, it doesn't really make sense how to graph it, right? Like not a lot. There's not a problem at all with you using your calculator and plugging in this function, looking to see what it does and have an idea of what to graph. But if you're actually given this, like, you're probably going to need to go ahead and just use some test points. I could tell that just logically, these are going to connect, right? That was an X-intercept, which means it's going to cross here. This is going to be a Y-intercept, which means it's going to cross, I'm going to draw it, which means it's going to cross here. These right here, it's not going to be able to cross. And knowing that an asymptote is something that my graph will approach, but not actually cross, I have an idea that this is going to do this. And because these connect and it can't cross there, it's going to do that. Like that's just logically, right? That's because I know that what I drew, it's not crossing. Now it's over here that there's something else that needs to be drawn. And that's why I'm saying if you use your calculator, you'll have that visual representation of like, okay, there's something else. And it's also why we plug in points. Okay. I don't know if I have this one. I think I did. I was trying to solve all this. Oh, wrong calculator. I'm getting it. Oh, lazy. So you would just hit y equals on your calculator. Boy. Y'all, if you're not super careful doing fractions in your calculator, like it's not going to be correct. You always put your whole entire numerator inside of parentheses divided by your whole entire denominator in parentheses. If not, it could just read it wrong. Can y'all see that? So NF equals, that's 3x minus 3 divided by x squared. If I actually graph it, do you see the graph right here? Okay, so it doesn't actually show you your vertical asymptotes, especially because they're pretty much just invisible, honestly. But so what we're going to do to plot the other points, like I get it. I mean, you just don't want to draw a regular line there. I'm going to probably look for points or maybe just test your, or like look at your test points. So you need to actually have stuff plotted over here. Yes. Okay, hold on, because I'm on a different thing. On the y equals alpha F1. Oh yeah, no, you could do that by doing, or I mean, you could literally just, I prefer parentheses personally, but yeah, that would actually give you like a fractional form and you could just enter on the top and enter on the bottom. Okay, so enter it however way. If you parenthesize it, you don't have to push that other button. And then when you graph it, you notice that you do have a second chunk of this graph over here. And because we do actually want to be able to graph that, you do second table. And if you notice, it's very blurry, but I get points here. Okay, I'm going to graph over here. So I'm going to look on my x-axis. What are these values? So I kind of know what to graph here. I'm not going to look on my x-axis anywhere over here. I already have that drawn. Okay. So on the right-hand side of that vertical asymptote, I have x equals 3. So you could either do what I showed y'all last time with the var stat so that you can plug in 3 and then it will use that function and just go ahead and solve it for you. Or if you just kind of come somewhere on your paper, 3x minus 3. You can plug stuff into here, but what I'm showing you now keeps you from having to plug in a 3 where these x's are. You don't have to do that because on our table right here at x equals 3, y'all can't see that, but it's 6. Okay, so it keeps you from having to do any of that little algebra. And then I'm going to go ahead and I'm going to pick the next x, which is 4. And that is actually in my table 4.5. I'm going to look at x equals 5, which is 4. So I'm just going to plot these. And then I have the ability now to draw the other half of this graph. So at x equals 3, it told me that it's at 6, which is right here. And then 4, x equals 4 is y equals 4.5. Which is here. And then x equals 5 is y equals 4. So that's right here. And again, logically, it's not going to cross those asymptotes. And so you are done with that problem. Does that make sense, y'all? Yeah? Okay. So let's go and do problem 2. I wanted to solve all of this so y'all can get through at least half of your homework. So I might need to go a little bit quicker. Okay. So for problem 2, it says f of x equals x squared plus x minus 6 over x minus 3. Vertical asymptote is denominator equal to 0. My denominator is x minus 3. If you set that equal to 0, what we get is x equals 3. And so at x equals 3, you just do a vertical line because that's your vertical asymptote. Horizontal asymptote, we need to know, is it bigger on the bottom, bigger on top, or are the exponents the same? And for this one, my exponent, the exponent on the top, my degree of this function, which is going to be the highest exponent, that's a 2. And on the bottom, it's a 1. So because I have bigger on the top, it told me that my horizontal asymptotes was none. That's that little thing we put out. So none. You just write none. And that's because the degree on the top is 2, the degree on the bottom is 1. So for this slant asymptote, it said that that happens whenever the degree on the top is higher by 1 degree, right? So because I've got 2 over 1 for my degrees, the top is larger by 1 degree. So it means I can find a slant asymptote. So what it told me to do was to take the numerator and divide it by the denominator, like literally do synthetic division or log division. So what I'm going to do, I was trying to give myself a little bit more room. I'm going to come right here. So what I'm going to do is I'm going to do, synthetic division. So that would actually be written as y because of my f of x. And that's x squared plus x minus 6 over x minus 3. Doing the top divided by the bottom. Okay, so this is in more of a long division form because that factor in the bottom, x minus 3, but remember to do synthetic division, I use the 0 of that denominator, right? So I'm not going to put in x minus 3, you just do 3. And then my coefficients are 1, 1, and negative 6. bring down your 1. Okay, multiply. 3 times 1 is 3. And then and the signs are the same, so it's positive. And then you combine 1 plus 3 is 4. I'm going to do 3 times 4 is 12. And then here we would combine. But honestly, I don't even care, right? So the answer that I get is a 6. I don't care when I'm finding asymptotes if I have a remainder of 0. The only thing I care about is this right here. That's my answer. That's going to be my M, and that's going to be my my B. So this equals M. This equals my B. My slant asymptote is going to be in the form of Y equals MX plus B. So I would have Y equals, my M is 1, right? So that's just 1x. And then plus my B, which is 4. Okay, so your B is your Y-intercept, right? In this form, we've done that in chapter 2. That's where it crosses the Y-axis. And then your M, that's your slope because it's 1. Like that rise over run would just be 1 over 1. So you just go up and over, draw a dot, up and over, draw a dot, up and over, draw a dot. So I know that it's going to cross at Y equals 4, which is right here. And then using the rise over run, I would go up to 5 and then over to 1, 5, up to 6, over to 1, 6. And I just, after a while, you just notice that you're doing this. And so going the other way, I would just be going down to 3 and over. So we did our vertical asymptote. We found there not to be a horizontal asymptote. And then we just now solved for our slant asymptote. Now we need to see what our X-intercepts are, Y-intercepts, and then actually graph it. Okay. So for your X-intercept, what you do is you set your numerator equal to 0. That's not X, that's Y. Here's X. Okay, so my numerator is X squared plus X minus 6 equals 0. And then y'all, we know how to solve this. Welcome to DUAC method. You could do quadratic formula. You could just do trial and error. Personally, if I see a way to just throw it into factors, I'm going to probably do that. And I know for a fact that I need X's right here. And I know that 2 times 3 gives me 6. And I know that a positive 3 and a negative 2, would give me a positive 1. So now the fact that I have factors equal to 0, you said each of them equal to 0. So I would do X minus 2 equals 0, X plus 3 equals 0. That means X equals 2, and X equals a negative 3. X-intercepts, though, personally, I'm going to write them as the ordered pair, okay? Which would be 2, 0, and negative 3, 0. This tells me where I'm graphing. This tells me what I'm plotting on this graph. So at 2, 0, we get right here. And at negative 3, 0, we are right here. Okay, so now we need to find our Y-intercept. The way you find the Y-intercept is you look at your function, you change f of x to y, you plug in 0 for your x's, and you solve for y. Okay, so writing this, I would have y equals, I'm going to go ahead and plug everything in now. Okay, that's 0 squared plus 0 minus 6 over 0 minus 3. That went to 0, that went to 0. That's 0. I've got negative 6 over negative 3. 6 times 3 is 2. Signs are the same, so it's positive. So that means that my y-intercept would be x is 0, y is 2. Graph that. So can you kind of see here, right? It's going to cross here. That's an x-intercept. It's going to cross here. That's a y-intercept. It's going to cross here. It's not going to cross these. Therefore, it does this. Now, by putting this into my calculator, x squared plus x minus 6 divided by x minus 3. Why is it only doing that? Did you say something? I didn't hear you. Yeah, that's what I'm doing. Bless you. There we go. So yeah, my window was it right. Okay, so those are the two pieces. Kind of gives you an idea of what it's going to look like, right? Now, because I can go to second table, the only thing I'm concerned with is how am I drawing it here? How am I graphing it here? So I'm only going to look at the points that would kind of line up with that, which would be like 4, 5, and 6. And if I look at 4 on my calculator, what I get is 14, 5 is 12, 6 is 12. So 4, 14, 5, 12, and then 6, 12. And then you're done with that problem. Okay. Okay, y'all. Vertical asymptote, excuse me, denominator equals 0. So that's x squared minus 1 equals 0. I would move my 1 over so that I can use the square root property. And then if I would take the square root of both sides, I would get x equals plus or minus 1. So this is saying at -1 and +1, there's a vertical asymptote. So here's my +1. Here's my -1. And then for my horizontal asymptote, what I do is it bigger on the top, bigger on the bottom, or are the exponents the same? For this one, it's bigger on the bottom, and bigger on the bottom told me that my horizontal asymptote, because it's bigger on bottom 0. And what I mean by 0 is my asymptote is y equals 0. So literally just kind of, this is y equals 0. I kind of did it a little bit. I went up a little bit on accident because I went too fast, but it's right there. And then our slant asymptote happens whenever our numerator's degree is higher by 1 than our denominator. That doesn't apply here, so just none. And then for our x-intercepts, what you do is you set the numerator equal to 0. So 4x equals 0, which is what? X equals 4? Well, nope, 0. Because I would divide both sides by 4. And so I get x equals 0. So that's saying that I've got an x-intercept at 0, 0, which is the origin right here. And then for our y-intercept, you change f of x to y, plug 0 in for your x's so that you can solve for y. So y equals, I'm going to go and plug in the zeros, y'all. 4 times 0 over 0 squared minus 1. 4 times 0 is 0. 0 squared is 0. Minus 1 is minus 1. 0 divided by anything is just 0. So I also get that my y-intercept is at the origin 0, 0. Okay, so we're going to graph this one so you can see it clear. Okay, so 4x closed divided by x squared minus 1. Nope, just kidding. Okay, so if we graph this one, and I'm still zoomed out, but it should show us. I'd kind of rather zoom in. Okay, if I hadn't done this, it probably wouldn't have been very clear what I was going for. Does that make sense? I have everything correct. You didn't do anything wrong here, but I would not have known to have done that. So that's what I'm saying. Have your calculator, use this. Once you have this, let's just start finding points everywhere so that we can like recreate this, okay? So I should have, and I didn't, given you 3 different table things here, because we're actually gonna need to test some points for our left-hand side, our middle, and our right. So let's make this our left, which would be right here. This is what I'm talking about. And so if I notice, a point that I could look at would be like -3. So if you look at your table at -3, that's supposed to be take roll. At -3, I get -1.5. And then if I do say -2, it's like -2.667. So at -2, I'm at -2, 1, 2. So it's almost all the way down here. And then at -3, I was at -1.5. So it's -1.5. And I know that it curves that way. And then for the middle, what I would do is I'm looking for somewhere in between 0 and -1 and 0 and 1, right? So I'm just gonna pick half. I'm gonna do my x at a -0.5 and a 0.5. If you look, you will notice that I get 2.7 and -2.7. So at a -0.5, I'm at 2.7. And at a +0.5, I'm at a -2.7. And I know that it kind of goes like this, and it goes down to here. And then for my right-hand side, X and Y, I looked at 2 and 3. I got 2.7 and 1.5. So 2 was 2.7, 3 was 1.5, and I knew that they connected in that manner right there. Okay, does that make sense, y'all? I went a little bit faster there, but having this let me know I had 3 parts of that graph, and then I just found the points that I knew I needed based on what I knew it couldn't cross, where my asymptotes were, okay? Okay. So let me take roll, and then whenever I'm done with roll, y'all are free to go, okay? Marisol, let me turn this off, y'all.